All right, class, take your seats, but not for long. It's Busch Gardens Day!
Yeah!
We're gonna work in groups to evaluate the physics project. Let's go!
Yo, let's try battering ram.
Yo, that's crazy.
Dude, I wonder how far we sink into our seats.
In this problem, we're trying to find the force that pushes up in our seats. So starting at our free body when it's at the lowest point, it is Fn up and mg straight down. In this given circumstance, we're moving in a circular motion, so normal force is known as centripetal force. The mass for the buoys are given. Establishing the 0 point in this situation, we can find a delta H max, and then using energy, we can substitute that potential under gravity equals kinetic energy, and we can solve for velocity tangential to the curve. After this, we can plug in centripetal force to equals mv squared over r, plug in our velocity, and solve that Fn equals 2 mg h over r.
Now put your hands in the air like you just don't care. They don't care. The louder you scream, the higher the ride will go. Change, change, change.
Man, that shit was fun. Alright, today we're going to find the work of the chain. And work is defined as the change in energy. So that's what we're going to find. We know that our roller coaster with us on it starts at rest and it starts on the ground. So we know that the initial kinetic energy and the initial potential energy are both 0. The change in kinetic energy and the change in potential is just the final minus the initial. And to find our velocity while it goes up, we assume it's a constant velocity. We measure some delta d along the ramp as the chain does its work, and we record the time using a stopwatch. We also know the maximum height of Apollo. There's actually statistics online, so we know the maximum height at the top of the hill. Using this, we just need to find the change in kinetic energy and the change in potential energy. You plug it in, kinetic energy equals 1/2 mv squared. V is just delta d over delta t minus 0, plus the change in kinetic energy is just mg delta h minus 0. And using all these variables, we can find the work of the chain. Chain, chain,
Hey man,
chain.
so I heard you're going to tech.
Dude, you're going rad for maybe 15 minutes away from each other next year.
Dude, that's pretty cool, yeah. So, like, do you think that the water applies friction to the roller coaster?
Oh, definitely.
This problem we're going to be finding the friction of the water right here. And the variables we're going to have to know are the initial height, the final height, and delta D of the water. So work is equal to the change in energy. And in this equation, we have initial energy and we have final energy over here. And this is work non-conservative, which is going to be friction. And the variables that we know are m, because we know the mass of the roller coaster, and V actual because we used a speedometer. And then we pull down the equation and we solve for work non-conservative. Work is also known as FD cosine theta. So in this equation, we're going to be using work non-conservative and moving this equation over to here, and then pulling D under the problem, which is right here, and then dividing by cosine theta. And cosine theta is going to be -1 because it opposes motion.
Hey, I'm pretty thirsty.